Hello students, welcome to Unique Classes. Today we'll be discussing the chapter Understanding Quadrilaterals. So let us start. For quadrilaterals, we'll just start with polygon. What is a polygon? Now let me first write down the definition of a polygon. A polygon is a simple closed curve that is made up of finite number of line that is made up of finite number of line segments. So what is a polygon? A polygon is a simple closed curve that is made up of finite number of line segments. Example, this is a pentagon. This is a polygon. This is a polygon, a quadrilateral. One, two, three, four, five, six, seven. This is a heptagon. This is again a polygon, a simple closed curve. Fine. Now, in the previous video, I have told you that a polygon can also be formed by joining triangles. As for example, pentagon. I can draw a pentagon this way. Now this is a pentagon. I have also told you that a circle can be formed by infinite number of triangles. This way and so on. So, is a circle a polygon? No, a circle is not a polygon just because the definition itself says that a polygon is a simple closed curve. Circle is a simple closed curve, but this is not made up of finite number of line segments. A circle has infinite number of line segments. That is why this circle is not a polygon, but this is a polygon. This is also a polygon, this is also a polygon, this is also a polygon. Now we'll discuss what type of polygon is this and what type of polygon is this later on. Now types of polygon. Based on the number of vertices a polygon possesses, it is classified as triangle, quadrilateral, pentagon and so on. So what are vertices? This is a quadrilateral. I have named it as ABCD, quadrilateral ABCD. So here A, B, C and D are the vertices. Okay, I hope you understood what are vertices. A, B, C, D, that is the edges. These are called the vertices. Okay, now based on number of vertices, vertices 3, then we call polygon as triangle. If the number of vertices 4, we call it quadrilateral. 5, pentagon. 6, hexagon. These are the numbering, serial number. 7 vertices, heptagon. 8 vertices, octagon. 9 vertices, nonagon. 10 vertices, decagon, and so on. It can have up to n vertices. It can have up to n vertices. Where n cannot be infinite. So polygon can have n number of vertices, but n cannot be infinite. It has to be finite as per the definition of polygon. Okay. Now we'll be discussing diagonal. Now we'll be discussing diagonal. And what is diagonal? A diagonal is a line segment connecting two non-consecutive vertices of a polygon. What is a diagonal? A diagonal is a line segment connecting two non-consecutive vertices of a polygon. Now what does this mean? Let me explain with an example. Explain it to you with an example. Say I take this quadrilateral. I name it A, B, C, D. So what do you mean by non-consecutive vertices? A, B, C, D are the vertices, we know. Now if it's a line segment, diagonal is a line segment joining the non-consecutive vertices. So in case of A, vertices A, what are the consecutive vertices? B and D. So we won't be drawing any line segment. So the only vertices that is non-consecutive in respect of A is C. So we join AC. Similarly, for vertices B, A and C are the consecutive vertices. D is the non-consecutive vertices. So we join BD. So AC and BD are the diagonals. Fine. Diagonal is it's a line segment connecting two non-consecutive vertices of a polygon. In case of this polygon, a quadrilateral ABCD, we have to join the line segment that is joining A vertices A and C and B and D are the diagonals. AC and BD are the diagonals of this quadrilateral ABCD. Now, there is a general formula for finding the number of diagonals of a polygon. There is a general formula for finding the number of diagonals of a polygon, and this formula is number of diagonals equal to n minus 3 by 2, where n equal to number of sides of the polygon. Fine. Now this is a general formula for finding the number of diagonals of a polygon. What is the formula? N into n minus 3 by 2. N minus 3 will remain in the bracket, where n is the number of sides of the polygon. Now let us use this formula to find the number of diagonals of a pentagon. We know that number of sides of a pentagon is 5. Therefore, number of diagonals will be n minus 3 by 2. This is the formula, where n equal to 5. 5 minus 3 by 2. So 5 into 5 minus 3 is 2 by 2. That is 5 into 2 by 2. So this 2 gets cancelled out. So 5. So according to this formula, a pentagon should have actually a pentagon will have 5 diagonals. Now let us verify this formula. Let me take a pentagon. Name the vertices A, B, C, D, E. Now AC is one diagonal just because A and C are not non-consecutive vertices. AD is another diagonal as A and D are not consecutive vertices. Fine. Now from B we can draw a line segment BE. This is again a diagonal, B and E being the non-consecutive vertices. BD, again non-consecutive vertices B and D, so B and D is another diagonal. Another diagonal we can draw from C. C to A we have already drawn, that is A to C, C to A, the same thing. We are left with only C, E. Fine. So the diagonals we found are AC, AD, BD, BE and CE. Total 5. So this, from the diagram also we have found there are 5 number of diagonals, and from the formula we have also found there are 5 number of diagonals. So this formula is fine. Now we'll be discussing convex polygon and concave polygon. Convex polygon and concave polygon. First point, what is a convex polygon? In case of a convex polygon, no part of the diagonal, no part of the diagonal will be in the exterior. No part of the diagonal will be in the exterior. In case of concave polygon, some part of the diagonal must be in the exterior. Some part of the diagonal must be in the exterior. I'll explain to you with a diagram, so need not bother. Second point, all the interior angles must be less than 180 degree. Here, in case of a concave polygon, at least one interior angle must be greater than 180 degree. Example, with example I will explain, that is with diagram I will explain. This is a pentagon A, B, C, D, E. Why this is a pentagon? Just because it has 5 vertices A, B, C, D, that is 5 sides of 5 angles. Fine. Now here, why this is convex polygon? Just because in this pentagon, no, what are the, let me first draw the diagonals. This, this. Now as you can see, none of the diagonal lies outside the polygon, that is outside the pentagon, whether that may be AC, AD, BE, BD, CE. None of the diagonal lies outside the polygon, outside the pentagon. Fine. And all the angles, all the interior angles, I mean to say all the interior angles, this angle must be less than 180 degree, less than 180 degree, this angle again less than 180 degree, this again less than 180 degree, this again angle again less than 180 degree. Fine. So the first part, no part of the diagonal will be in the exterior, so none of the diagonal lies in the exterior. Okay. Next thing is, all the interior angles must be less than 180 degree. This angle is less than 180 degree, 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 this angle. Why I'm saying this, this angle, this angle, this angle, this angle and this angle all are less than 180 degree? Just because if it would have been greater than 180 degree or at least 180 degree, it would have to form a straight line. Fine. Okay, I hope you understood what is convex polygon. Now convex polygon. Again, this is also a pentagon, A, B, C, D, E. Now the diagonals are diagonals are here the diagonals are AC, AD, BE, BD and CE. Here also the diagonals are AC, AD, BE, BD, CE. Now as you can see, CE lies outside the polygon. This the initial polygon was this. This was the out A, B, C, D, E. This was the initial polygon. I mean this is the polygon, that is the pentagon, and this CE is a diagonal that lies outside the polygon. So some part of the diagonal must be in the exterior, okay. And the second criteria, at least one interior angle must be greater than 180 degree. Now this interior angle, this interior angle, this has to be more than 180 degree, just because if I draw a straight line this way, so this angle would have been 180 degree. Now something in addition to this 180 degree will obviously greater than 180 degree. Fine. Here angle CDE greater than 180 degree. So I hope you understood what is the convex difference between convex polygon and concave polygon. So now we will be discussing regular and irregular polygon. Regular and irregular polygon. Now what is a regular polygon? If all the sides and all the angles of a polygon are equal, okay, then it is regular polygon. If all the sides and all the angles of a polygon are not equal, or we can say unequal, then it's a irregular polygon. As for example, equilateral triangle, square, regular pentagon, etc. Example, isosceles triangle, that is a triangle having two sides and two angles are equal. Rectangle, pentagon. The term regular itself says that all the sides and all the angles are equal. If I say it's a regular pentagon, that means a polygon having 5 sides and 5 angles, where all the sides are equal and all the angles are equal. Right? So this is basically regular polygon, a regular polygon and irregular polygon. Okay. Now we'll be discussing angle sum property, angle sum property, angle sum property of a polygon, or I can simply say angle sum property. Now we know that in case of a triangle, I name it as ABC, a triangle ABC. Angle A, that is this angle, plus angle B, that is this angle, plus angle C, this angle, is equal to 180 degree. This is something which we already know, that the sum of all the interior angle of a triangle is equal to 180 degree. Okay, now we'll be using this very simple concept to find the sum of interior angle of a polygon. Say I take a rectangle, say quadrilateral A, B, C, D. Then I draw a diagonal BD. Now as soon as I draw this diagonal, so this quadrilateral has been divided into two triangle, that is ABD and the other is BCD. This is one triangle and this is another triangle. So the angle sum property, how will we find triangle ABD plus triangle BCD. Now for triangle ABD, angle A plus angle B. By angle B I mean this angle, plus angle D. By angle D I mean this angle. For triangle BCD, angle B, I mean to say this angle, plus angle C, this angle, plus angle D. So this will give 180 degree, this will give 180 degree, equal to 360 degree. The sum will be getting 360 degree. This is one way of finding the sum of all the interior angle of a polygon. Now as this is a simple polygon, that is a quadrilateral, it's quite easy for us to find this sum of interior angle. If there would have been multiple sides, say 20, 30 sides, then how will we be finding that? We can't be keep on drawing this diagonals and summing all the triangles. In this case we have a general formula. General formula for finding the sum of interior angles of a polygon. General formula for finding the sum of interior angles of a polygon. Sum of interior angle is equal to -2 into 180 degree and -2 into 180 degree, or we can also write this as 2n minus 4 into 90 degree. You can use either this or this, both are the same thing, right? If we take common 2, then 2 into 90 gets 180 degree, that is fine. So either you can use this one or you can use this one also. So let me try this on, say, pentagon. Okay, fine. Here n equal to number of sides of the polygon, number of sides of the polygon, where n equal to number of sides of the polygon. Now pentagon, in case of pentagon, n equal to 5, that is number of sides equal to 5. So sum of interior angle equal to 5 minus 2 into 180 degree. 5 minus 2 is 3 into 180 degree equal to 540 degree. Right? So using this formula, we found that the sum of interior angle of a pentagon, it can be a regular pentagon or an irregular pentagon also, but the sum of interior angle will always be the same, that is 540. Okay, now let me verify this via the original method, that is with the help of a diagram. This is a pentagon. I'll just divide into, draw this diagonal, again I draw this diagonal. So A, B, C, D, E. So basically on this one triangle, this is another triangle, and this is another triangle. Okay, so found three triangle, that is angle ABC plus angle ACE plus angle CED. Now, sorry, triangle ABC, triangle ACE, and triangle CED. Now we know that for it, the sum of interior angle of a triangle is equal to 180 degree. Sum of interior angle of a triangle is equal to 180 degree. Sum of interior angle of a triangle is equal to 180 degree. So 180 plus 180 plus 180 is equal to 540 degree. Now this, both the answers are same, so this formula is correct. Fine. So now we'll be discussing exterior angle. That is the sum of exterior angle of a polygon. Okay, just remember this, that in sum of exterior angle of a polygon will always be equal to 360 degree. It can never be more or less than 360 degree. Whether it is a triangle, a quadrilateral, a pentagon, hexagon, heptagon, whatever that might be. But the sum of exterior angle of a polygon will always be equal to 360 degree. Right? So in case of a regular polygon, this, as we already know that in case of a regular polygon, the interior angles are equal, so the exterior angles will also be equal. in case of a regular polygon, all the interior angles will be equal. Okay. That is, if I take, say, example, regular hexagon, that is 6 sides. Regular hexagon has 6 sides. That's a regular hexagon. So in case of a regular hexagon, I have already told you that the sum of exterior angle of a polygon is equal to 360 degree. So each exterior angle will be equal to the sum of all the exterior angle is equal to 360 degree. Now how many sides does a hexagon has? 6. So 360 divided by 6 equal to 60 degree. So in case of a regular hexagon, each exterior angle will be equal to 60 degree. This is the answer. Right? Now, in case of a regular, in case of a regular, in case of a regular polygon, each interior angle is equal to n minus 2 into 180 degree by n, or can also say that is 2n minus 4 into 90 degree by n. The above part, this one you already know, that is the sum of interior angle of a polygon, n minus 2 into 180 degree. Now if it is a regular polygon, obviously all the interior angles will be equal. So how many angles will there be? That is n divided by n will get each interior angle. So this is all for polygon. I hope you understood what I'm trying to explain. In the next video, I'll be uploading a few questions along with the solution. If you have any queries or any questions, feel free to comment, or if you have any suggestion also, kindly don't hesitate to comment that in the comment section. And if you liked our video, then do like, subscribe and comment. Thank you for watching.